Let me welcome you to the 58th lecture of surface mining technology online NPTEL online certification course. This is the third lecture on stability of bench slopes. This is third and final lecture of this stability analysis, and in this lecture we will discuss about the circular failure. But before that, as we do in every class, let us retrospect once again what are the learning background required for surface mining technology course. The learning objective set for the surface mining technology course and the expected learning outcomes from the participants of the surface mining technology course. And these are some of the textbooks and reference books, as in the last two class also we have discussed. For slope stability, the recommended books is the book written by Brady and Brown. Another book is available with written by Brown only. There are many more books are available. Pit slope manuals are also available. Slope stability softwares are also available. Apart from that, free MATLAB codes are also available for analyzing the slope stability. It is very important for an engineer who is assigned with the slope stability analysis job to understand the geological disturbance very good. That is very important, because slope stability largely depends on the geological disturbances, their orientations, their deep angles, deep directions, these are very important. So, that part is significant knowledge in that area should be there for a slope stability engineer. Now, let us retrospect the whatever we have covered so far in surface mining technology course. We have started with the current status of surface mining in the world. We have completed the phases of mining a deposit and every unit operations associated to each phase. We have completed the commencement of surface mining with box cut. We have discussed in details the drilling technology, drilling patterns, their machine details, machine deployment details, all these are discussed. We have discussed the blasting technology. We have discussed the blast design techniques for surface mine and how to assess the results of a blast. We have discussed the blast free mining technique, that is the excavation of repair, the cuttability of repair, the performance of repairs are discussed. After that, we have discussed the excavation carried out by the shovel, especially for the loose rock mass or the fragmented rock mass, and their performance, their cost analysis are discussed. The transportation system is also discussed with special reference to the shovel dumper combinations, the allocations of dumpers with the shovels, their performance analysis, their cost analysis are discussed in details. We have covered the operation of surface miner, their methodology, pit layouts, performance analysis, cost analysis are discussed. We have discussed the operation of drag line for direct casting of material. We have discussed the three mode of operation of drag line, the extended bench method, direct casting method, side casting method, extended bench method, all these are discussed and along with their performance and cost analysis. We have discussed the high wall mining technique. We have discussed the designing of high wall mining technique. We have discussed the bucket wheel excavators, the different mode of operations, the performance analysis and cost analysis of the bucket wheel excavator. We have discussed the high wall that haul road maintenance and haul road constructions details are discussed. We have discussed the dimensional stone mining method. We have discussed the seabed mining method, and we have discussed the other auxiliary mining operations required like secondary boulder blasting, sump pit construction, all these are discussed. And this is our final topic we are discussing about before closing of the mine, that is the analysis of slope stability we are discussing. This is the third and final lecture of the analysis of stability of slope. The set objective for analysis of stability of slope is to understand the necessity of stabilization of pit slope, to understand the different types of slopes, to understand the possible slope failures, and to learn the slope stability analysis. So, we are already covered, we have seen there are three types of, mainly 3 to 4 types of slope stability analysis is carried out. The planar failure, wedge failure and circular failure are the main. Toppling failure is also there. So, planar failure, wedge failure, toppling failure we have already covered. This is the circular failure we are discussing about. So, circular failure is basically a rotational failure of in which the rock mass or overburden dump, which are basically the loose formation, failed completely following a arc of a circle, and this slips occurs suddenly and this is the material is come down, a huge quantity of material come down in that case. So, this is one circular failure of a natural slope which is occurred, can be seen in this picture. Now, these are some of the examples of the circular failure occurred in the mine. You can see the quantity of material, slided down here is very high, and that is why the rehandling cost, any of machines which are under operations are already damaged because of this. So, the consequences are very high in this case, and that is why it is very important to control this circular failure. So, circular failure is important one, because no one knows in the how the arcs are being developed inside, that is prediction is very difficult, and that is why this failure occurred if not sufficiently analysis is carried out beforehand, this cannot be controlled. So, that is why circular failure analysis is very important. Nowadays, slope stability radars are there to analyze the movement. Apart from that, surveying techniques are there. Formation of cracks in the surface are tried to be monitored. So, all these technologies are adopted, but circular failure is a huge devastating failure. In general, the consequences are considered to be very high. So, circular failure is occurred in common loose and unsolidated material. In mining, generally occurred in overburden dump, but may occur in the top benches where the loose materials are there and highly weathered and fragmented materials are available. In those cases, the occurrences of the circular failure may happen, and that is why proper monitoring is required. Circular failure is categorized in 3 ways. One is slope failure. In slope failure, if the bench is like this, a part of this bench is fall down, and you can see this arc is formed, this bench is fall down like or slide down in a form of arc here, that is called slope failure. This arc of rupture meets the slope. So, this is formed and this meet the slope. So, this soil become dilated and moved out. So, this is the slope failure. This when the arc is meeting with the toe, this is called toe failure. This is occurred when this rock is very competent, and this is a homogeneous loose material. Then this type of failure occurs because this homogeneous loose material on any condition, the destabilizing force is becoming more than the stabilizing force. This material slide down like this. So, this is often occurs with increase in the weight because of the moisture content or the saturation. So, that is why in loose soil in rainy season this type of failure occurs. Sometimes this is also occurred because of some high pressure acting at this place, say some shovel etc., are working in this place. Sometimes because of their weight it may occur also. So, this type of failures are often found in case of soil material, in mostly in homogeneous cases, and this analysis must be carried out considering the this type of formations in that case. And third one is base failure. In base failure occurs when the floor material is very weak. So, if this material is very weak, in that case this cannot withstand the load of this one. So, this try to heave at this position, and by this way this complete rock mass is slided down towards this. So, this is called base failure. Base failure is often occur if these are slope, this portion is very soft, or there is some very weak layer. Weak layers are existing in below ground, then often this type of failure may occur, that is called base failure. Now, let us look into some of the slope circular failure of the slope. So, this can be seen how the material is being slided down in a circular failure. This is one circular failure video of a mine. See, these are the two drill machine, we have already told you. These are the two drill machine, and this see circular failure of the material is still coming down. The manpower has been withdrawn because of this failure, but drill machines could not be withdrawn because these are already stuck, must are already stuck, drill rods are inside the hole. So, see this complete material is now slided down, gradually it is moving out in this direction, and the see all this material is coming down. So, complete top benches, all the top benches, overburden benches are fall down. So, this is another view of the same failure. This is another view of the same failure. See, still the drill machine can be seen, and the base rocks is completely falling down. There is this dozer was also under operation there, but this is fortunately withdrawn. This is the complete top benches has come out, slided down in a circular failure. This from the top, all the material is coming out. So, this is a huge sliding. More than 1.5 million meter cube of material has come out, and 3 drill machines are stuck in this circular failure. So, right time observation and monitoring is very important in this case. Otherwise, the withdrawal of the man machines to save their life is will not be possible if the proper monitoring cannot be carried out. Here there is a little bit problem with the monitoring system, that is why it could not be machine could not be withdrawn, but fortunately manpowers are withdrawn with sufficient time ahead before the failure reach at the position of working. So, now look into the details of this circular failure. Circular, there are various methods to analyze the stability of a slope failure under for the circular failure analysis. One is the limit equilibrium method. Apart from that, finite element methods are also there, discrete element methods are also there, the Bishop's analysis are also there. So, there are different methods are there. The method of slices in conjugation with the limit equilibrium method are the most common method for analyzing the stability of overburden dump slopes. So, let us have one look into this. So, generally the method of analysis of slices are carried out. The complete slope is divided into a number of slices. So, now this is 1, 2, 3, 4, 5, 6, 7, 8 slices. So, now in these slices the potential failure mass is divided into a number of slices and analysis is done for each slice. The overall factor of safety is computed by taking the ratio of summation of restoring force and the driving force. So, for each slice the sum of the stabilizing force and sum of the destabilizing force is considered. So, as this is considered, so summation, so overall stabilizing force is coming and overall destabilizing force is considered, and that is considered as the factor of safety. So, this is one let us have how this slice 4 is considered here is shown. Let us look into this. So, if we are considering this one, these are the E1, E2 is the interslice normal forces, X1, X2 is the shear forces, L is the width of the base slice, B is the width of the slice, H is the height of the slice, N is the total normal force, alpha is the angle of inclination of slice, and R is the radius of the arc of the surface. Then the total weight of the slice is considered as W is equal to gamma B H, gamma is the density and total normal force is this one, pore water pressure is this one. If we are considering this, then this can be come out with that the when K is the linear factor of determining the increase in the linear force with depth, N is the number of slices, E is the horizontal force acting on offered by the adjacent slice, and N is the normal force. In that case, the force can be calculated using this formula. This formula is almost same for this one and this one. So, this is alpha is the angle we are considering at this place and n is the normal force. So, that is why which is acting at this position, this is the destabilization component and this is the stabilizing component we are considering at this case. Now, this from this ordinary method of slices, the factor of safety can be considered like this, where T r is equal to W r sin alpha and T m can be computed like this. So, the factor of safety is calculated using this formula. Now, in this limit equilibrium method, the assumptions are made like this: interslice forces are not considered here, if there is any forces are considered. When the Bishop methods are used, the resultant interslice forces are considered as horizontal. When Janbu's method is used, the resultant interslice forces are considered horizontal and empirical correction factor is used to account for interslice shear forces. And when the Morgenstern Price method is used, in that case the direction of the resultant interslice forces is defined using an arbitrary function. The fractions of the function's value needed for force and moment balance is computed, and when this method is used, Spencer method, the resultant interslice forces have constant slope and throughout the slide mass is the assumption considered, and with this assumption these methods are available. These are the different methods considering the methods of limit equilibrium method, and by this way generally we go for analyzing the circular failure of a slope. This ends the stability analysis of the slope for the mines. In mines we have seen in the pit the most common failures are planar failure and wedge failure. Occasionally where the loose soil benches are there and not properly maintained, circular failure may occur there, but in the wedge dump only failure which is occurred, that is the circular failure. So, for the wedge dump circular failure analysis is very important. So, that is the end of the stabilization of the slope. Thank you.